So let's talk about what we mean by continuity in this unit. We say that a function is continuous if there are no breaks, jumps, or holes. One tool that people use is they say that they can trace the graph without lifting their pencil. So for this rational function, y is x squared over x squared plus 1, we don't have any vertical asymptotes, we don't have any holes, and so we're going to call this function continuous. There are two types of discontinuity. The first one is non-removable, and this is going to occur whenever you have a denominator that can be 0. So whenever you have a rational denominator, whenever that rational function is 0, then that value of a is not in the domain, and you have a point of discontinuity. Sometimes we call this an infinite discontinuity. But make sure you know that it's not removable because we can't algebraically do anything to get rid of it. You're always going to have a vertical asymptote at a non-removable discontinuity. For this problem, you look at the denominator. X minus 2 is 0 when x equals 2. So x equals 2 is a non-removable discontinuity. There is something called a removable discontinuity, and that's when you can algebraically manipulate the equation to be equivalent to your original function at every point except one point. So you see, if I look at this graph right here, x plus 3 times x plus 2 divided by x plus 2, I see I have a discontinuity at x equals negative 2 because I can never have a 0 in the denominator. So the domain of this function is going to be all x such that x does not equal negative 2. However, if you look at this, I can factor x minus 2 out of both numerator and denominator and make this algebraically equivalent to x plus 3 at every point except x equals negative 2. So because we were able to remove the discontinuity algebraically, we call it a removable discontinuity. Removable discontinuities result in holes in your graph. Now, let me warn you, when you're on your calculator or you're on technology, they will show this as a solid line. And your graph won't necessarily indicate that it's a removable discontinuity.